Was India ever ready for indigenization and in avionics at that point?
The idea was that let's try something that's tough.
The rising power of the graph of Bharat today. Technology, business acumen, marketing, I think a wonderful combination. I think really welcome. I think we in Bharat should be really happy for people like you, with people like you. Thank you.
Namaste. So, this is a new series of talks that we are going to be doing on Sangam Talks, new series of interviews, podcasts for Swarajya Conclave. India at 2047. What is the vision of an India in 2047? Is only a Viksit Bharat with $13,500 US per capita, should that be the only measure of India in 2047, or should there be other measures? What about dharma? What about kama, beauty, aesthetics, pleasures of life? What about artha as dharma also? And this is our hope, to engage with the government and the bureaucracy, legislature and bureaucracy, to share and to bring to light, to surface to the top issues of the business environment, of the cultural environment of India, of the educational environment, tourism, all of this, various sectors we're going to be focusing on, to surface them up to the legislature, bureaucracy, hopefully judiciary as well, of what needs to change in an India of 2047. What do we need to achieve to have an India of our dreams? You will see in today's talk my guest talking about that we are looking at full end outcomes, end systems, but we actually have to approve way lower down small units, go to the semiconductor level, and actually develop incentives and encouragement programs for entrepreneurs like my guest Venkatesh to build systems, build deep tech, new technology. Specifications change, after giving out, contracts for building systems on some specifications, and then endlessly get delayed, and then there are, by the time new technology has come in. So we've got to be faster in the bureaucracy, in defense procurement, in just how we think. We're not thinking nimble enough, we're not thinking fast and agile enough. We're looking for perfect solutions where good enough work really well. Procure fast, use, fail, learn, procure fast. We have the money. We need to change our way of thinking in the legislature and of course in the bureaucracy and the end users such as the defense. That is the message I collected, and hopefully you will enjoy this talk. Thank you. We have today Venkatesh Sai, who's the co-founder and technical director of Zuppa Geonavigation Technologies. They are taking on the Chinese drone manufacturing industry and making indigenous drones, and we know the Rahul Gandhi incident, so we'll talk about that as well. Welcome, Venkatesh. Tell us a little bit about your maybe a quick introduction about your drone manufacturing company and what do you do, how do you indigenize, and what level of indigenization do you have?
So, Zuppa Geonavigation Technologies, to start off with, we define ourselves as a deep tech company involved in control and communication systems for aerospace and defense technology. So, we do not specifically say anything about drones, it's generally for aerospace and defense. It's primarily because the company started off with the concept of making control and communication systems for airborne platforms. And the mission of the company has always been to deliver world-class electronics, avionics specifically. Avionics is electronics for aerospace applications, which is made in India. So it has taken us a long journey. We started way back around 2008 or so, and around 2012 we got into actually, starting to understand what are the different nuances within an unmanned vehicle. And we came to understand that a flight control system or an autopilot is a very core piece of technology. It's like the motherboard of your laptop. You have a motherboard for the laptop. Similarly, an autopilot, colloquially called an autopilot, is what that is for a drone. We said it's something we should make in India and it should be developed. So, to very crisply, put it across, we control everything across the entire cyber physical stack of a drone. A cyber physical stack includes the hardware, the firmware, the operating system, the interface protocol, the ground control station. So it's a combination of hardware and firmware and software. So we have developed all of this from scratch, including communication protocols and data exchange interfaces. And now, of course, we have 4 different verticals. One is selling of avionics, where we sell autopilots, communication systems. So other OEMs like Throttle Aerospace, Neo Sky, and E-Plane Company, and all these kind of people. Then we also sell our own drones, which is Ajit series of drones. That is primarily meant for the forces, defense forces, as well as we have certain civilian use cases. Then we have an interesting vertical product development as service, because we are a core tech company. We also make some cool stuff like ballistic computers for guns. And then we have made certain, laser pointer and lasing systems for, again for ballistic computers. Then we are making some arrestor barriers for fighter jets for the Indian Air Force. Then we are working recently. We are in discussions with the Indian Navy on a quantum positioning system for what we call as zero dead accuracy for navigation in GPS denied environments. So yeah, that's a third vertical. And fourth, we have an education vertical also, where since we have accumulated a lot of knowledge, and see, we have accumulated knowledge in a domain which really India doesn't have a history in, that is avionics, electronics for aerospace. So we felt also there should be a way that we should be able to pass this on. So we have a initiative called Drone Labs, where we are partnering with colleges and institutions, and we are giving them in-depth knowledge, not just flying. We don't consider flying as a very high skill. Stuff like flight dynamic models, flight control laws, how is mathematical modeling done for aerospace application. So yeah.
Very nice. Before I hand over to Colonel Ramakrishna, quick question on, you started in 2008, and was India ever ready for indigenization and in avionics at that point? Did you run into clearance issues, license Raj type things? And where are we now at this point in time with clearances and government mandates and so on and so forth?
So definitely when we started off, it was just the concept that we should make in India, and I was also working, part-time on this, and then it became full-time. I was working corporate before that. The idea was that let's try something that's tough. Let's see how it works. It was not really at that time when we started off, we didn't have a commercial angle to it. I was a tech guy. So, how tech guys think. We first look at the technology and then we figure out, oh, there's something called commercial. So that happened to me around 2016-17. That's when I got in, certain people who have experience like Sai Patlabiram, our MD. And recently we have a CEO also who had joined. So yes. So when we started off, it was tough. It was that you couldn't, certain sensors were licensed. So, we had to make do with regular commercial grade sensors. So the accuracies, then actually that was a blessing in disguise, because it taught us how to improve our software filtering capabilities and all these kind of things. Of course, after that aspect resolved, and now specifically in today's context, the push for indigenization is very strong, thankfully.
But what about licenses, and what about Army's ability? Is the procurement process easy enough for Indian companies doing such high, not high value, but it's real time. The procuring for warfare situations. How is the environment?
So, if you put it as a comparison to other countries, yes, there is scope for improvement, definitely. I think also there is a part of the regime which is understanding that yes, there something like this has to be done, where companies who have a very core level of skill set and which is vital from a national security perspective needs specific encouragement and support. See, because all of us are extremely focused on the tech one aspect, then we have our day-to-day running of the company. But beyond all of these things, if you look at it from a national, if you look at this technology from a national security perspective, when we started off in 2008, there were about 6 companies in the world making proprietary autopilots. Today there are about a dozen. So that means, in nearly 1.5 decades, maybe another 6 companies added on. So that means the technology has a certain intrinsic value, which is quite quantified in this nature, and we are seeing it because of the fact that things that we were not even associated with, weapons and all these kind of things, people are asking us to pitch in and solve those solutions. So there is some amount of encouragement which has got, but I feel it has to be a lot more holistic, lot more integrated. These companies like ours who have taken time, developed very core technology, need to be encouraged further by the government in terms of procurement or even in terms of support. Like for example, we have SCOMET regulations for exports, which takes about, in the current day, previously it used to take about 2 years to get an approval, now it takes 3 months. But 3 months also is a significant period, for companies who are, like an SME or, an SME like us. So I think, yeah.
Even for exports?
Even for exports. Because it is a controlled technology, dual use.
Okay.
See, like for example, a nuclear weapon has a destructive use and it can be used in warfare. It has a civilian use. Similarly, drones is another technology like that. If you look at it very clearly, you can use the same drone for, say, dropping flowers or dropping a bomb. So because of which it comes under certain SCOMET regulations. That's why it comes under SCOMET. Now, as an industry person, as everybody, we understand all this. But further support for specific indigenous technology, yes, should be there. I think that there is more to be desired.
It's really great to have you here. I think you represent today, people like you and your company, the power, the rising power of the graph of Bharat today. Technology, business acumen, marketing, I think a wonderful combination. I think really welcome. I think we in Bharat should be really happy for people like you, with people like you. Thank you.
Thanks, Lord.
So tell me, you having a number of vendors, number of items which go into your drones. You have a number of vendors, then how do you ensure the quality assurance of those parts? And you have your own laboratory, you were telling me. So how is that done?
So as I said, there are two aspects. You have for any A&D, as what you call aerospace or defense product you supply, and generally even any kind of civilian product like this mic that I'm wearing has the environmental conditions and the electronic, the EMI, EMC. So you have certain standards, like in the civilian side we have IS 61000 for EMI, EMC, which has, so your device has to be compliant and you can get it tested anywhere for that. And electronic speed controllers that we obtain have this IS 61000. They need to be assembled with the IPC 610A standard for assembly. They need to be designed as per IEEE 2221. So See, once you have the vision through the supply chain down to the chip, you understand that standards form an integral part of the system. You have a standard for design, like if you take a PCB, it's IEEE 2221. You have a standard for production, which is IPC 610. Once it's produced, you have a standard for that specific module, which is IS 61000 in this, MIL 461 A to F for defense. And once all that is done, you need to finally put it in a box or a kind of a casing. That is tested against environmental standards, which is, in civilian you have the IEC 304741 or IS 9000 part 2 and 3. And in defense, you have JSS 5555855.
I guess the question also perhaps is, or at least I can pick on that, do you have the ecosystem, manufacturing ecosystem for handling all of this in India, or did it build over?
See, if you look at it in electronics, yes, we do have that. It has taken us time to build and understand. See, I remember the first PCB we made in 2015 or so, we didn't know anything of standards. So, as a tech guy, we had put tracks all over the place. We found out, we switched it on, it doesn't work. Then after that, the next version that we made, it kind of worked. We gave it to the EMI-MC, Samir was a lab in Chennai. We gave it for compliance testing, it failed. And then they told us, they didn't have also a clear idea as to what has to be done. Luckily, we had certain mentors, who was, because we were working on an AD project. And then after that, we learned those standards. Then we learned about manufacturing. So it's been a learning curve.
Which is fine.
Yeah.
The ecosystem?
Yes, the ecosystem today exists for testing these objects.
Okay.
So you can today go to somebody like TASL in Bangalore, get your EMI-MC done. You can go to, Samir in Chennai, which is STQC does it for software here in Delhi. So we have standards, we have testing facilities available. And today, the good thing that happened post 2018 was that testing for MIL standards, which is Aerospace and Defence standards, moved out of facilities like DRDO and others, which are government. See, government comes with its own level of inertia. Yeah. So, a typical, say, JSS 5855 test, previous to 2008, used to take a year. After that, what has happened is the MOD, Ministry of Defence, under the DDP, Department of Defence Production, has authorized certain private laboratories like Tata and Astra Microwave and Accord to perform these tests and give compliance certifications. So with that, something that takes a year has now come down to 4 weeks, 4-5 weeks.
Very nice. So that's good. And what about manufacturing? This is testing. Manufacturing, do you do that yourself or are there ecosystem partners?
There are, so like for example, we have our entire PCB is manufactured by a company in Gujarat, which is...
So the ecosystem
exists. It exists. Yes. It exists. See, it exists to the level of the PCB, not below that. If you look at semiconductor tech, that does not exist today. Of course, we have been working and we have recently been able to get our hand on India's first microcontroller, which is Tejas 32. And we are trying to see how we can include that in our products. But yeah, I think, that is one aspect that also the government understands they are working towards. Yeah, but generally, if you look at it at the overall level, there is facility to produce, there is facility to test.
What is the speciality about Zuppa? How do you integrate these different aspects, different software for different products, which go into the microchip systems? How do you do that? Is it something very special for you, or is it commonly done?
See, now, for example, I personally have about 1 international patent and 2 Indian patents on a system which is called Disseminated Parallel Control Computing for Real-Time Systems. It's a very complex term. But actually, see, what happened was that I can tell you the origin of this. It will eventually come to answer your question, but you might like the origin story. See, when we were making autopilots in 2014, see, an autopilot is something which a drone cannot fly without. It's like a motherboard, like a PC or a laptop cannot function without a motherboard. Similarly, drone cannot function without an autopilot or a basic flight control system. See, if you see, a FCS is a very, very complex thing when it comes to flying, because the moment you add the third dimension, that object has mobility in any direction. So even a RPM difference of say a few tens of an RPM difference between two motors can cause instability if left unchecked. So the flight control system literally does something which is managing chaos. Chaos is the randomness of the motors, winding, air resistance, all that put together. The flight control system's job is to make sure this doesn't go, it doesn't become random. Manage entropy is what we call it. So we were trying to understand what is the best way in which we could, create a control system. We were trying, different things like your smartphones, multi-threading, multiple apps, and we realized, that used to crash after some times, because in defense they have MTBF, mean time between failure, has to be in excess of 1000 hours. So that means system has to work robust, it has to work at high speed, and it has to be, secure. So we said, we were trying to find a solution. It didn't, we tried regular approaches. It just happened that one day I was going from home to my house to the office. I was driving my bike. That time I had a bike. So suddenly there was some cow which cut in front of the road. It normally happens in Indian roads. I swerved the bike. But it so happened that day that I observed my brain at that point. So like, what is our human control system doing? How is it able to do it so well? See, we are able to drive a bike, we are able to fly a plane. And we are able to do both efficiently and scalably. So we said, okay, we should look at this. Maybe this could be a method of our control system. So we realized that, as humans, while controlling anything, we have a reflex action, which is immediate, spontaneous, immediately avoid the object or, make sure the system is stable. And you have thought out process. They work simultaneously. You can try it next time, if you're going down the road, something cuts, you will swerve your bike, but if you observe your brain at that time, you're still thinking of tasks like, where do I go forward, take a left turn, there might be too much traffic there, it might be better to take this road, while you're avoiding this object at an instant. It's a beautiful system. So we realized we had reflect process and a thought out process. What did we do? We made an electronic version of this and called it Disseminated Parallel Control Computing for Real-Time Environments.
And you have a patent on that.
It's commercialized?
Yes, it is commercialized. We have created 60 plus products with this technology. And we have, as of today, close to 430 deployments of our autopilots. And out of that, 150 plus are on the Ajit Scout drone with the defense. As a company, we have taken it from a paper up to a product. So to answer your question in terms of our basic method of, our products and all these things are created with special softwares. The depth to which, like for example, it takes about 18 months for us to train a regular embedded engineer who works, say, in Bosch or one of the good reputed MNCs to start working on these mission critical applications. So yeah, manpower is there. There are challenges there also.
Tell me, today the most popular drone, I think, is this HJ1 or something from the Chinese.
DJI.
Oh, that's the same one, Rahul Gandhi one.
Yes.
Yeah, just tell me, how are we going to compete with a thing like that? It's cheaper, is it? Is that why people are buying it, or is it really sophisticated? Will your product be better than that?
So to put it into a perspective, in terms of performance, that means flight characteristics, our products in some cases match DJI and they exceed it. We have done tests, stress tests, which are equivalent to what have been done on DJI, like what we call as leaf blower test is one. You take a leaf blower and blow it at 75 kmph, check whether drone loses stability, nudge tests. So all these things we do. Where are the challenges? Now the challenges are arising in the fact that the peripheral components like motors, ESCs, camera payloads, these again like a FCS take time to build. Now we are one of those examples who have somehow been able to come up with this in our Indian environment. But in general, the startup environment towards deep tech is not very conducive as of today, especially from the encouragement from the end users as well as the government setup. Yes, we have grants, we have programs, but deep tech, frankly, money as such is one aspect which is required, and in fact, in some cases, more money is required to develop a component than the end product. And that is the kind of understanding which today, the forces are slowly orienting towards. They're coming to that realization that developing this accelerometer, say, inside that smartphone is more expensive than assembling that smartphone. It's a slow realization which is coming. But the Chinese have had a head start in this, and especially something like DJ has, to put into perspective, around 2014-15, when they also were commercializing, we were also at the similar level of tech. There was not too much of a gap. But then the drone ban came. So as official people in 2014 onwards, we couldn't even manufacture or sell drones. So we had to find other applications. Whereas through other channels like the grey markets and all that, Chinese products are periphery. So yes, there is a gap of around 5 to 6 years, what I see as of today. Given the correct amount of incentives as well as encouragement, I am quite sure that companies within India can, like we have a beautiful motor manufacturer called Vector Techniques in Hyderabad. They do a wonderful job of manufacturing motors. They need more encouragement.
What do you mean encouragement?
Encouragement meaning, see, now the procurement process. Now if
With the government you mean?
with the government, if the procurement process states that I have a component level certification, that means if the Indian component is certified to a certain standard or it meets a certain compliance, then automatically it can be bought within the product. That's not there today. Tender to tender basis, they have to specify a motor specification or something like that. In many cases, they don't even specify the specification for the motor. They just say, I want the drone to fly for this many hours, for this many minutes, for this much range. And you are, the OEMs or the other people are allowed to use whatever they can assemble and deliver this parameter. What we see there should be a change is that, and which is slowly happening, is that the forces come up with a list of whitelisted components saying this is your whitelisted ESCs, communication system, motors, payloads. These are all the vendors. Now from these list of vendors, they can use products to make their drones, and the defense can procure the same. Then it becomes easy for component manufacturers like us. Why do I consider myself component? I was originally a component manufacturer making electronics. Then I found it so tough because nobody was buying my electronics. So I said, okay, I would rather make the drone itself. Otherwise, as a company, we always had the vision that we wanted to only supply the chips.
Being only avionics.
Only the avionics. But we went into the entire because of the simple fact that there is no mandate today to buy Indian technology. They say they want made in India, but how? Now, who are the motors manufacturers? What are the standards you are complying this to? If I say today take my controller, I want to get it complied to a certain standard, and after I get it compliant, anybody within the defense ecosystem who want to supply a drone to defense is open to use my product. Like that, there might be another 3-4 people who will get into the flight control system space. Then what happens, it creates a kind of a barrier, at least for us as component manufacturers, basically to develop our technology as well as commercialize it. So we don't have that, import scare, which is already, see, the Chinese manufacturers of components are quite mature today. They are quite mature. They have a number of variations. They have a number of features that they have offered. It will take some time because of the amount of time that we have lost in the past to catch up. These are some initiatives that can be done to encourage this industry.
So just detail this out a little bit, and maybe naive questions, but really like to understand. So you were saying that suppose you're a component manufacturer. So how should the government whitelist the component and the vendor basically say this component of Zuppa technologies is approved and you can use it in your drones? So is that how tendering should happen, you're saying, versus how it happens now? Can you tell me the difference?
So as Sir had said, the core lies in standards. See, today if you look at a tender, there is no standard written for say a motor. So you're free to use any kind of standard, you need a 4006 number motor. It could be, non-standard, it could be IS61, nothing. So what I'm saying is for each component, there are enough expertise in the industry to help the defense say that for each component, these are the compliance standards which should be there. Anybody complying to this gets whitelisted.
Got it. And how is it currently? There is no standard.
There is no standard on component level.
See, having been in quality assurance in the defense, one major issue is the government expects the manufacturer to come to the government and say, I have manufactured this, here are the specifications, please accept it, sir. मैं हाथ जोड़ता हूँ, please accept it.
So which means that the people who are issuing the tender do not have an understanding of the component level standards. Would that be accurate, say?
Yes.
Would that be accurate?
Which exists.
Yes.
Correct. So that is the status today. See, it was in the drone space specifically when you say. Till now, everybody was in a thing of drone उड़ना चाहिए.
उतनी हाइट पे उड़ना चाहिए, इतना पेलोड लेना चाहिए. स्टैंडर्ड्स, कंपोनेंट्स लेवल स्टैंडर्ड्स की कोई बात ही नहीं है.
बात नहीं था.
समझ गए.
So now it's realizing they are, after certain incidents which have happened, which all of us know.
But this is what happens when non-technical people do tendering for defense and other things, no?
Even technical people are bound by the rules and regulations, and the L1 is the biggest noose around it.
L1 is one aspect which is of, see, like for example, now we are one of those unique companies because of certain volume of scale in some other businesses. We are able to offer our products at equivalent import prices as compared to Chinese. Despite because of the fact that we operate across multiple industries, so there is a kind of the components cost reduces. Whereas, like for example, and that's because I'm operating electronics, I'm using kind of the similar processors in your smartphone and all that, so it's easy. Whereas if you take a motor manufacturer, that motor is very specific to that type of craft. Now today the volumes don't exist in India to justify, to be able to offer it at import paired pricing. So that's where L1 becomes hard. In my perspective and interaction with some of the people within the procurement, especially DDP, they are coming out with a system where they are going to be giving an indigenization rank for different products. So a higher indigenization rank, so anything above 60-65% according to the matrix once evaluated, you would be able to get a certain concession on L1, meaning L1 plus 20%, L1 plus 30%. So even up to that level. So supposing somebody quotes 20 lakhs, and so it's quite, they are coming out with things, but again the pace, speed at which things happen, like for example, cyber security frameworks are the need of the hour. It has been under discussion for some time now. I am hopeful it should come out soon.
See, the major issue in the government of India is the decision making. Any decision which is taken is questionable, and one anonymous letter is enough to trigger off questions in the parliament. And people are naturally scared. Tomorrow there will be a CBI inquiry, there will be a CVC inquiry, there will be so-and-so inquiry. So it's very difficult for a person to take any, even though he says it's the right judgment to be taken, it's very difficult for him to take. This is unfortunately the case.
So everybody is getting clearance after clearance after clearance so that nobody can point a finger at one person to say, oh, you were part of creating a mess. I heard this from a bureaucrat, an ex-bureaucrat.
Nobody dares to say. See, if it is L1, it's very easy to say 20% de do. So then,
Who has to approve that?
So 6 levels of approvals क्यों कर रहे हैं?
the person who signs first or recommends first, just 20% will be the guy who will be ultimately targeted. And I have seen this happen in service. And it's very difficult for even the most technically qualified.
Exactly. So now if you put it from an external perspective, somebody like us or companies like us who are outside the governmental ecosystem. See, we do not have any backing. We do not have infinite funds. Yeah. But still we have to work within these constraints. It's quite tough.
Yeah, absolutely.
And I would say that is a large reason why deep tech really hasn't taken off in India. It's slowly coming, but it's not really shot up and taken off. Is only because it takes a lot of time, effort, money and commitment from the end customers to develop something.
And you mentioned that the encouragement and incentives not only from the government, but you said end users also. What do you mean by that?
So like for example, sir would have definitely experienced that in the forces. Would be that today I start off with a certain specification of this project. It has to meet so and so specification. Then after 3 months or 4 months of trial, then the specification suddenly is changed. So the goalpost keeps changing. It has happened to us on one project. We developed for the mech infantry. We developed one version, suddenly the specs changed. Then we developed the next. Now finally, after achieving 92% compliance on the specifications also, orders are not being released because it has taken so long that the technology has become obsolete now. It has taken 5 years for us to do all this. And now that the relevancy of the platform on which this system is supposed to be mounted, the platform itself has become irrelevant.
Terrible. And this is happening because?
See, the major problem with defense industry in India is this.
Well, this is the forces itself, the Indian Army, I'm supposing.
See, what happens is any item of defense, from concept to, from concept, then you go to a prototype, then you do the testing and all that, and the gestation period is quite long. And the amount of the money involved is very heavy.
But that's where they're investing.
Yeah. No. See, it is possible for him to invest, provided he is assured that this time, if it passes, next time he will get the order.
That's correct.
Yes.
Now, unfortunately, what happens is, he has spent, say, 10 crores or 15 crores in developing a product. He managed to get the first order. The next time the tender is floated, somebody will quote 10 rupees less and it will go to him.
Yes.
So all that he has got is wasted. And the other guy we know cannot produce it because he has no experience in that at all. But the fact that he has quoted 10 rupees less, his order goes to him. He will not supply that store and armed forces are without that particular store.
Why do they change specifications along the way? And by the time finally it's come, I mean,
many times it does happen. See, we have to consider that our friends on either side of the border are also procuring the latest possible equipment, and we have to see, what is the state of our equipment? Can it stand against his equipment tomorrow?
So instead of looking for a perfect solution, like I always said while running my business, please don't make perfect the enemy of good enough.
That's true.
What is good enough, procure, roll it out, use it while you look for next version. So we have to be fast as well in our procurement. Be willing to waste some money,
here,
even if it's wasted. I mean, nothing's wasted.
Now, if we say US is going for F-35, they already must be working on F-40. And the amount which the research work, billions which have been spent, is spent by the Defense Department. It is given to Hawker and Siddeley. It is given to these guys
So
for doing the research.
For research is also paid. Nobody pays for research.
Nobody pays for research. So like for example, we have a program like that called IDEX, which is for basically innovation for defense. It's called Idea Exchange. Basically, it comes under Defense Innovation Organization, and they have done a decent enough job where, like suppose if there's a 3 crore project that you raise, 50% is borne by Ministry of Defense, 50% has to be borne by you.
Okay.
Now the challenges, where the challenges are coming up here, it's a good program. But the challenge that is coming up again is that when we started off, say we started off with XYZ specification. But today, suppose the specification is changed to X plus 1, Y and Z. I'm not getting my order. Okay, I've got my 50, like say we had put up 3 crore project, I got 1.5 crores from government, great. Now that remaining 1.5 crores that I've invested, in most companies, in most contexts, it's from investors. Regular PE investors or VC investors or angels, HNIs. They demand, return on investments. Yeah. That becomes that hampers this entire project because of the simple fact that now the end user we have met the specification, but the end users change the specification. They are not giving orders. Investors are not willing to further fund the company. The grant is over. What is the other way that this could be worked out? I mean, this is something that I just thought of, previously. So actually, Technology Development Fund, TDF, under the Department of Science and Technology has a very successful program which very few people know of called TIFAC, Technology and Innovation Forecasting Committee. We were a recipient of one among the 18 companies to receive a very low interest loan from them for commercializing our autopilot technology. This is way back in 2015. The advantage with a loan, with a moratorium, is that I get all the money upfront for development. I can focus on development rather than finding investors to get in my 50% contribution. And more significantly, a loan is something you can always repay it and get closed, or it can, the government can do other ways to offset it. Whereas the moment you take a 50% equity from a private equity investor and the end user doesn't commit to buying your material, you're stuck. As a founder, I'm stuck.
So IDEX has to change to perhaps two things. Either remain 50-50, but then give committed orders of a certain value if you deliver to the specification within the timeline. Correct. Then the order has to be committed and protected in court of law.
Correct.
The other is give upfront 100% for that R&D and maybe have joint IP or transfer or
joint IP, or have a moratorium of 5 years to repay the loan. See, within 5 years there should be some way that company, even if the defense is not willing to commit to giving the order, within 5 years they would have definitely already found some other avenue of using the technology. So there are programs, but I think those programs need to again be thought of in a little bit of...
Hopefully this conversation helps. Hopefully it will reach the powers to be.
Coming on the technical issues, tell me, we are talking of drone, communication systems. Now, are dealing with a single drone at one time, or can you deal with a swarm of drones?
So, if you look at it, the communication system that we have developed, it's called the Zuppa Edge RF radio frequency. Zuppa Edge is a platform that we made primarily for communication, multi-point, point-to-point as well as multi-point communication. So the communication system that we offer, you can connect theoretically up to 255 nodes to it, different points, practically about 20 or so. So we do offer a swarm solution for our series of drones where up to 20 drones can be operated from a single ground control station. And this is more and more becoming relevant in the warfare situation for, like used to have carpet bombing being done by airplanes before, now it's being done by drones. So it's changing in this way. Again, coming in the communication part of it, see today all of us have the computing aspect of the communication, but even a company like us, being very frank, are importing the radio frequency chipset. The RF chipset that we use either is from Canada or is from Taiwan based on the pricing. So those are again aspects that need to be looked at further in terms of development, because communication is a very important aspect of warfare. When we talk about anything, whether it is communicating over voice or relaying a position or directing a radio guided missile, a communication chipset is something that we should have developed by now. It's not come to this thing. I think those are areas that have to be focused on.
That falls under the semiconductor PLI and all
Exactly.
of that the government. So are there companies coming up in this area?
See, actually, you will be surprised to know that in Bangalore, there are quite a few companies who have been designing semiconductor chipsets for some time now. They have been designing for larger companies. Yeah. So we have the ability to design. Today, a number of the semiconductor like Tata Semi and others who have set up is for something called packaging. That means the silicon, basically the wafer comes from outside. Wafer is the actual this thing, and then the connectors and box, basically casing and all that is put here. It's a first step, but ultimately see, we have one end of the core which is design. Now the question is, how do we prioritize saying yes, these things, these 5, 6, 7 items have to be made for sure, at least designed in India, and then get it produced in some way. I think the prioritization is required.
Or sounds like an IDEX grants. If they just do this, that start designing so that the whole industry ecosystems comes up, it probably would happen. So these communication chipsets is where the hacking happens. For example, I had heard that we had procured some drones, I think for the Indian Army, and then later realized that there was a snooping case. And this happens because of the communication chipsets being international. And then,
if you don't mind, I go a little detailed into this. So yeah, so communication basically is, like, very simply put, now if both of us are speaking in English, everybody will understand. Now suppose if we switch to say speaking in Hindi, some people would understand. If we say speak in Tulu, both of us, nobody will understand. They can hear what we are saying, they can hear the sounds coming out, but they can't understand what we are saying. That is actually the vulnerability which is there. It is not per se in the communication aspect. Is the communication system is one gateway towards the vulnerability, but the core vulnerability lies in the what we call as the data command and control protocol, the language in which the GCS and the autopilot, the flight control system, communicate. The vulnerabilities which came up were because these languages being used were open source. So because it being open sourced, an encryption on open source, like say hi, I say hi, how are you? Everybody can understand. Now encryption on open source, like say the open source message that I'm delivering to you once a second is hi, how are you? Encryption on this is say how high are you? It's all jumbled. Somebody can put it back together because they know that hi, how are you is going every once a second. They know the message that's going once a second. They just need to understand what's the key you have used. But suppose I give you some type of gibberish like blah blah blah, something like that, you won't be able to understand it. Only the recipient and the transmitter would be able to understand. That's why command control is far more important than the communication channel itself.
That is the cybersecurity framework.
That's the cybersecurity framework.
So you're saying that India has to develop its own proprietary cybersecurity frameworks and ask companies to say follow these? Is that how it works? Naive question maybe.
No, it's a beautiful question. I would love to give an example which is extremely successful in India itself. I'm sure all of us will know about eMudra, BIM, and DigiYatra, and M-Aadhaar. These are. Now you're, say like for example, eMudra works on a Chinese Oppo smartphone, works on an iPhone, it works on an Android, Android phone that I have. So it works on the most compromised system, which is like an Oppo, as well as it works on an iPhone and still secure. So it's not the question that we have to make some cyber security framework. We have already got it thanks to the Aadhaar system that some of the great minds of the IT industry put together. The same thing has to be adapted here. It has to be, and the challenge that is coming up there is that many companies within India, especially in the drone space, don't have control over the core aspects of the system like the FCS, communication module, the relay chipsets. So they are not able to implement these things. So there are solutions existing within our ecosystem. We have to just adapt it for this.
Who has to adapt this? Sorry, government has to build these.
Here is what I'm asking. See, we are also procuring, you say, basic chipset from, say, Canada. You're getting something else from somebody else. And they all must be speaking different languages. Basically, you've got to put them all together. And is this where you draw up your own, language or whatever it is to get them connected together? Is it possible for you to ensure that nobody else can butt into that within your small thing?
So, as I said, very technically, if you get down to it, I'll have to explain about headers, footers, and all that. But generally speaking, once you create, say, your own protocol, own language of communication, which is there, and then you have certain encryptions that you add on it, it becomes extremely difficult even for, say, a quantum tool or a hack exploit, as what you call as a quantum exploit, a quantum computer aided exploit, brute force exploit, to hack into this, because they don't know the base layer. We don't know what is being sent.
Yeah, correct.
We are just able to see, so like for example, you're just able to see noise. You're not able to see what's being sent. So that has to be done. And the government end users again have to mandate something like this.
So which means the defense.
They have to come up with a framework saying, if you are going to supply anything to us, it should comply to cyber security standards, so and so, like OWASP 3.0 is being used by MeitY, Ministry of Electronics, for all your BIM users that.
So we have it for those, and we do not have it for, what would you say this? We do not have it for communication.
So if you call the communication control, everything put together is called a cyber physical stack.
Cyber physical stack. So that we do not have standards for.
We don't have standards for the CPS, as what you call. It is not only in drones, it is also in other unmanned as well as certain other applications also in defense.
Why are we limiting this to defense? Well, it can be for Shipping Corporation of India, it can be for...
Actually anybody, so that nobody can hack into at least Indian systems, even if they are being used as fire drones, fire extinguishing drones. Fair enough.
The question in all this is who's going to take that initiative and implement it.
This is why we have the Swarajya Conclave 2040 with the vision of India 2047, so that we can have these conversations and start pushing government through such conversations on what does the industry need, where do they need to uplift and deliver more as services, as money and ecosystem encouragement and incentives, like you said.
Where do you see these drones going forward in the next 5 years or 10 years? We have swarms, and we have seen that being used in Ukraine this time. Now, of course, that's for, but in civil use, what are the civil use for drones?
So civilian use cases are actually quite a few. We are currently doing a decent enough rollout in terms of perimeter surveillance for large plants. Logistics is a big application which is coming up, because in terms of not our local hyper local logistics of delivering toothbrush and coffee and all that. I frankly, personally, if you ask me, I never think that'll really scale. What will is medical delivery in remote areas. That is something that is of major consequence. Then there's a very interesting, shipping use case in terms of replenishing vital, consumables on ships docked at sea. That's an application Airbus is working on in Singapore with. So civilian applications, apart from that, pesticide spraying, which is already being rolled out.
Like everybody is talking about agriculture.
Agricultural pesticide spraying.
It's just spread too much. And I saw, those fire extinguishing drones. Is that interesting? That will happen?
I think that might. It's a kind of hype. As of today, we can't really say whether it will happen, whether it will not happen. But for sure, I know that hyperlocal logistics is not going to scale. It might happen in terms of as a fad or a gimmick.
Yeah. Some money will go behind it and say then crash after 5.
But it's not going to take off.
Nasty guy can even have tear gas shells.
Yeah. All of that. Absolutely. That's
Not
non-civilian.
putting out water into that. Okay.
Yeah. Wonderful.
What is Zuppa looking forward to? You say 2047. That is the in thing these days.
Oh, 15, 25 years, 10 years, 20. What are you looking for? Where are you going to be?
Forward something.
See, we have the technology, like for example, this DPCC that I explained to you about. Like how, we talk about Intel i5, i7, i9. i7 is or i5 is a data computing architecture. It's an architecture for computing data, correct? Similarly, for an architecture for processing control is what we have made. In fact, we are the first company to get a data computing architecture patent, and it took us 9 years to do that, because it had so many oppositions from everybody from Toshiba to Amazon, which we had to justify, and DRDO and others also. So we see that over time, products that we make, which are currently as what we call as SOMs, system on modules, will become SOC, system on chips. We will become more a kind of a semiconductor player. The vision, of course, in terms of business will be to expand our drone lineup, all those things. But if you talk about the company's vision, is that we want to move further back the chain. Currently, we are making modules. We see ourselves making chips. It will happen. If these encouragements and all happen in the right way, it will happen. It's a matter of time. That's the direction in which we will go.
Wonderful.
Great.
More power to you.
Why did you choose Chennai instead of Bangalore? Bangalore, I thought, was the hub of startups and all that.
So, number one is because I was from Chennai, and that is one aspect. But we have seen one disparity that is there between Chennai and Bangalore. Bangalore has a lot of hype. So, also, very specifically from a manpower perspective, if you talk about it, the salary levels are quite high. And we typically, as a deep tech company where a lot of investment goes into technology, cannot afford expensive manpower, because we don't have continuous. We have like one hit businesses. Now, of course, it's become continuous, but when we started off, it was hit or miss type. So in that case, Chennai was better.
Since you were mentioning about that, a lot of research goes on a product to be developed, and by that time you are able to develop the complete product. There's a mandate which comes in, of course, now
Specification change.
Indian government requires much better product, or maybe something which is of a modern technology. So just to understand that, is now government also open? Because what we have also learned that government is also promoting our defense startups to sell their products to other countries also, because there are other countries which are in our neighboring also, like Maldives and other, which are not very high end, but they need like drones and need more defensive equipments and techniques which could help their
Yeah, so just in defense exports, you're largely saying, but that question generally has been answered by IDEX and their specification changes and all. They need to be.
They need to commit. See, one aspect is making the entire system. Making the entire system is relatively quite easy. Like, it's far easier to make a car than an engine. Yeah, it's always far easier to assemble a phone than the micro.
Same case with Tejas right now, right?
It's the same case.
The Kaveri engine and with
Kaveri engine, because in the
GE engine being delayed endlessly. $500 million more.
So where is our focus? We should have instead of having the top-down approach every time, we should look for once from bottom up. You have opportunities to also export components. You'll be very surprised, but France, close to about 80-85%, I was reading, of their exports of defense equipments come from electronics. Safran, basically, or Safran and Airbus. There are possibilities, but we have to look more down the value chain. We are just looking at the surface. We are just looking at the top, the entire thing.
Yeah.
Yeah, one last thing about exports. Are you looking towards exports of what you're manufacturing? Have you ever thought of that?
Yes, we are actively looking at enhancing our export capabilities, and we have supplied certain autopilots and electronics. We have done projects for also certain foreign entities using our flight control system and electronics. It is now gaining more steam because with the sentiment globally, like today, I read a few days back that foreign, Western tech companies are looking at A, B, C, anything but China. So there, India comes as a nice alternative because we have already proven that in the IT space we are a good technology partner. Okay. Now, of course, but previously it was more of manpower, but now it's more of tech. We have shown that we can do it. So it's quite attractive. So we are looking at exports. Exports is quite attractive as of now. So AI has a profound impact on defense and generally aerospace technology and drones in general. See, today if you are seeing systems are becoming more autonomous, they are becoming more intelligent. It's not by chance. Today AI models, like for example, a model which identifies an object tracking model, AI model can fit within maybe even the memory available on this remote, on a TV remote. Yeah. So because of which the future of general drone use cases as well as defense and aerospace use cases, we will see a lot more involvement of AI because it makes the functioning and the deliverables of the system easier to achieve, and it also gives the ability to counteract against variable environmental conditions, like different like for example, if you have an AI powered stabilization system for a drone, you could predict wind patterns based on the oscillation of the drone itself. There's the research that's going on now. Similarly, today the defense is looking at using AI to counter the counter drone issue, where multiple drones coming across the border and by all kinds of non-friendly organizations. They are looking at a kind of a striker drone which we are working with them on, which is called the Ajit Scout Striker AI, where our drone basically has a AI model which is able to recognize other drones up to a distance of close to 150 meters, and if you lock onto the specific drone once detected, it will go and hit it. So yes, AI is having a profound effect, and it's here to stay. And more companies, organizations are adopting it within their systems to enhance efficiency, reduce variability in terms of various conditional operations, and other aspects.
Thank you very much. Lovely speaking to you. More power to you. Hope you succeed and win and become bigger and bigger and do very well for India and for yourself. Thank you very much, Venkatesh.